Okay, the next conic section that we're going to study is an ellipse. Okay, and there's a couple definitions and vocabulary words here regarding ellipses that we need to know. But first of all, the ellipse, the definition of an ellipse is it's the set of all points in a plane whose distance from two fixed points in the plane have a constant sum. Okay, we'll look at a picture here in a minute. But these fixed points are called foci. There's the plural focus. There's two of them. Okay, the line through the foci is the focal axis. Okay, and the point on the focal axis that's midway between the foci is the center. And the points where the ellipse intersects its axis are the vertices of the ellipse. Okay, so those are the words that we're going to be using in regards to an ellipse, along with a couple other things we'll get to in a minute. Okay. Looking at the picture that I mentioned a minute ago, okay, this would be a typical ellipse. Notice that the focal axis is horizontal in this case. When we did our warm-up earlier, we had an ellipse that was taller than it was wide. That focal axis then is going to be on in the y direction. It's vertical. Okay, and think about that definition that we just read. Okay, what that means is this: if I pick any point that's on the ellipse, let's just say that's the point that I choose. Okay, any point that I pick, when I draw a line from the focus to that point, and then from that point to the other focus, okay, that distance right there, call it D1 and D2. Okay, that distance does not change. That total distance, D1 plus D2, is constant. So here's what I mean by that. So if I did measure this and I figured D1 was 5 and D2 was 3, that means that total distance there would be 8. True? If I picked a different point, let's say right here, the second point, and I did D1 plus D2, okay, it would also equal 8. So no matter where I pick the point, okay, those two distances together are always going to equal the same number. Now, are they always going to equal 8? No. Okay, they're going to equal some number, whatever it may be, depending on how big the ellipse is. Okay, but any point we choose on the ellipse is going to have that property that those two distances are going to be constant when we add them together. Okay, so let's take a look at the key information dealing with equations for an ellipse. We have two different types. Okay, one that is of this form, the other is of this form. Keep in mind that the way to tell the difference between these two, because we know that addition is commutative, okay, the difference that we have here is that this one has the a squared underneath and this one has the b squared underneath the y, whereas in this one the a squared is underneath the y, okay, the x squared is beneath the b squared is beneath the x squared. And what you want to recognize here is that with an ellipse that a is greater than or equal to b. Okay. All right. So in simple terms, whichever one, the x squared or the y squared, whichever one has the bigger number underneath it, okay, that's going to tell us where the focal axis is. Okay. So in other words, if the x squared has a bigger number underneath, then it's going to be an ellipse that is longer than it is tall. Okay. If we have the bigger number that's underneath the y, that means it's going to be taller than it is wide. Okay, so that's what we want to look for. Okay. So again, if the a squared is underneath the x squared, the focal axis is going to be on the x-axis. Okay, and the focal axis is going to be on the y-axis if the a squared, the bigger number, is beneath the y squared. Okay, the two foci are going to be related to the two numbers underneath the x squared and the y squared. Okay, they're going to come from what we call this letter C. And I'm going to skip down to this part right here. This is probably the most important part. Okay, the relationship between A, B, and C is right here. Okay, and of course, if we know A and B, then we can find C. Or if we know A and C, we could find B. Or if we knew B and C, we could find A. All right, so if they give us the equation, then we have enough information to figure out what C is, because we'll know what A squared and B squared are. Okay, and we need C to find the two foci. The vertices are going to be dictated by the bigger number, A. And again, the vertices are going to be the endpoints of the focal axis. Some books also call this the major axis, so I may say that from time to time because I'm more used to saying major axis from my work. Okay. All right. And the other two parts here talk about the semi-major axis and the semi-minor axis. Okay, when we say semi, we mean half of. Okay, so half of the major axis is going to be the A value. Okay, half of the minor axis is going to be the B value. Now this information, okay, besides the two semi parts, okay, is on your notes. As you can see, you have the two equations. Okay, I have the two versions on there that are where we don't have the center at the origin. Okay, the slide that we're looking at now is center at the origin. We'll see the other slide in a minute. Okay, we have the focal axis, foci, vertices, the Pythagorean relation to make sure we know how to determine what C is if we know A and B, vice versa. And then we also have the two pictures here. This, of course, is the first one where we have the major axis horizontal. Okay, this would be the second one where we have the major axis vertical. Okay. All right, so we're going to go ahead and take a look at a problem. Okay, see if we can determine the vertices and the foci of this particular ellipse. Okay. The first thing that we want to recognize is that this is not in the right form. Okay. It does not look like one of these where we have x and y and we have a number underneath. Okay. And the other key element is that to be an ellipse in the proper form, there needs to be a 1 on the right-hand side. If there's not a 1 here, that's a problem. So looking at this, we don't have a 1 here, we have a 36. But if we take and we divide all the parts by 36, okay, that will give us a 1 on the right. And if we reduce these fractions, it would leave us with x squared over 4 plus y squared over 9 equals 1. Okay. Which would give us something that is in now the right form. Okay, we can see that there's no h and k, so the center would be 0. So I'm going to go ahead and start graphing this, kind of like what we did with the parabola, even though it doesn't ask us to graph it. Okay, very helpful, in my opinion, to graph it so we can identify all the important parts. And I mentioned earlier that if the bigger number was underneath the y squared, okay, that the major axis then is going to be vertical. So we're going to center here at the origin. Okay, this number right here, keep in mind, is our a squared. So that means a would be 3. So when we graph this, we're going to want to go 1, 2, 3 up, 1, 2, 3 down, and that right there is going to define our major axis. Okay, make sure we don't go 9 up and 9 down. Remember, that number is a squared, not a. Similarly, b squared would be 4, therefore b would be 2. So that means to the right and left, we'd go 2, 2 left, 2 right. Okay. And at that point, once we have those key 4 points drawn, we can actually draw a picture of the ellipse. Okay. So that would be a picture of the ellipse. Okay. They asked us to find the vertices. The vertices, of course, then are going to be at 0, 3. 0, negative 3, so we'd label those as V. Those are our two V's. Okay. And then the two foci, we know, are going to be inside the ellipse. Okay, if we're going to find the coordinates of those, okay, we need to find C. So we know that a squared equals b squared plus c squared. So for us, that would be 9 equals 4 plus c squared. 5 would equal c squared. So we'd get c equals plus and minus the square root of 5. Okay? And that means that if we're going to find those, that means we start at the center. Okay, whether we're centered at the origin or not, we still start at the center, and we go in the major axis direction, because the foci are always on the major axis. Okay, we'll go up radical 5, which is going to be 2 point something. Down radical 5, which is going to be 2 point something. And if I plot them in the right spots, that would help. So here's your one focus. Here's the other. So that would be focus 1, focus 2. And if we had to label those as points, we'd say 0 radical 5, 0 negative radical 5, and those would be our two foci. Okay. Questions so far? All right, let's take a look at another one. This time, instead of finding some parts, we're asked to actually write the equation. Okay, it says that we want to find the equation of the ellipse with the foci at 2, 0, negative 2, 0. The minor axis has a length of 2. So once again, I'm going to help myself by drawing a picture. It'll help me make a decision on which equation I'm going to use. So if my foci are at negative 2, 0, and 2, 0. That would be those 2 points. Foci being on the major axis always, that means that it's going to be a horizontal major axis. That means my general formula then is going to be x squared over a squared plus y squared over b squared equals 1. So I can identify which is the right equation to use. Okay. All right. I also know that the center is going to be in the middle of the 2 foci, so that puts my center at 0, 0, so I don't have to worry about the h and the k at this point. Okay. And then next, I need to see if I can figure out what these two are. Now, it says the minor axis has a length of 2. That means the minor axis only goes from 1 to negative 1 then, doesn't it? If the entire length is 2, it would go from 1 to negative 1. And like we did in that last problem, the distance from center to the outside of the ellipse, okay, that's b in this case because it's the minor one. So therefore I would already have one of my pieces of information right here. It's 1 squared, of course, but if I square it I still get 1. And then the other part I need to figure out is what goes beneath this x squared. I need to figure out what a is. Well, remember that a squared is equal to b squared plus c squared. And I already know b is 1, so 1 squared plus. And then c squared, remember, is the distance from the center to a focus. Okay? Or the c is, I should say. So from center to focus, that distance in this case would be 2. So we'd go 2 squared, and we'd get 5 over here. So we'd get a squared equals 5. So that a squared, and really we don't need to really do anything with that equation because don't we want a squared to be underneath our x squared? Okay. We could take the square root and figure out what a is, but they didn't ask us to do that, so we don't really need to. All they've asked us for here to do is write the equation. So once we figure out what that a squared is, plug it into the right spot and we're done. Fair enough? Okay. Questions so far? All right. Okay. What we're going to do then for tomorrow is work on the assignment from section 8.2. And what I want you to do is just the problems that are only centered at the origin. So if you get into problems that involve having an h and a k, okay, go ahead and save those for tomorrow. Because we're doing this for 2 days. We're going to do some more notes tomorrow with center not at the origin. Okay, so when you get to those problems, go ahead and stop. Okay, so I can work on those right now.